In chapter 3, we have looked at a lot of different types of equations. And in all of our equations, we've come up with solutions that said x equals this, n equals that. We've had a variable equals some type of number, whether it was a whole number, fraction, decimal, whatever. But there are situations in which we have what we call special solution sets. And the two main ones we're looking at here are the solution sets all real numbers and no solutions. All real numbers happens when you get an equivalent equation or inequality. That means that the left side and the right side are the same. Or for an inequality, it's essentially a true statement. So we have 0 is less than 2, which is true. And when that happens, you're going to have all real numbers as your solutions. Every number in the entire number system that are real will be true for that equation. You can plug any number in and it will work for that equation for that variable. And then no solution means that you're getting essentially a false statement. 0 equals 2, which is not true. 0 is greater than 2, also not true. When you get a false statement, that means your solution set is no real numbers. There are no numbers that you can come up with in the real number system that will work for your equation or inequality. You can try out as many as you want. No number can be replaced with your variable to give you a true statement. And essentially what I think about when I'm solving these is that the all real numbers, we're looking for a true statement. That's not x equals something. We're looking for the variable to disappear, but we're left with a true statement. And then for no solution, we're looking for the variable to disappear, but we're left with a false statement. So let's look at a couple of these examples. I've got two that are equations and two that are inequalities. So these two look very similar. Number one, we're going to start with simplifying. Let's do distributive property first. And we're going to go ahead and combine our like terms. And you may notice that there are the variables 2x on both sides. So if we went and subtracted 2x to both sides, they're going to cancel. And we are left with negative 15 equals 6, negative 6. This is a false statement. Negative 15 does not equal 6. And this tells us that our equation has no solution. I'm not going to be able to type or to put any number in for x and get a true statement. So this is no solution. And you can also use the empty set with the circle and a line through it to represent no solution. Let's look at the next one. Very similar steps because these two equations look very similar, essentially just different numbers. So we're going to distribute and then we'll combine like terms because we have these two variables on the same side. And you'll notice that that leaves us with the 9 x's on each side, but it also leaves us with minus 30 on each side. Now let's say we didn't see that they're the same on each side. We'll subtract the 9x from both sides, and that leaves us with negative 30 on both sides. This is a true statement. Negative 30 does equal negative 30. This means that our solution set is all real numbers. And you can write your solution set using the notation that I just highlighted. For these, we are looking at inequalities, and we are still looking at true statements or false statements. We're going to start with simplifying. We have 2x on both sides. Leaves us with 10 is less than or equal to 10. Since that has a less than or equal to, this is a true statement. 10 is less than or equal to 10. This is true. And so our solution set is all real numbers. And we can write our set like this. Oh, highlighter. For this next one, the steps are similar because these inequalities are very similar. We're going to combine like terms. And we can already see that these are the same on each side, but I'm going to go ahead and subtract 4x from both sides to give myself 3 is less than 3. And notice that this statement is very similar to the statement we got on the left side. When we got 10 is less than or equal to 10, we got a true statement. However, on this side, we have 3 is less than 3. This is actually a false statement because 3 is not less than 3. 3 is equal to 3. And if we don't have that or equal to symbol in our inequality, it's a false statement. And so this has no solution. Let's see if I can make that a little bit better. There we go. And so we have no solution. You can also have the empty set like that. So if you have a false statement, we get no solution. If we have a true statement, we get all real numbers.